Hi, today we're going to be going over the Java solution for Leetcode 240. Search a 2D matrix 2. Write an efficient algorithm that searches for a value target in an m by n integer matrix. This matrix has the following properties. Integers in each row are sorted in ascending from left to right, and integers in each column are sorted in ascending from top to bottom. So, what does this mean? Well, essentially, we have a sorted matrix and we want to find an element. So, of course, we can just go ahead and do a linear search through it as a sort of brute force solution, but we're not really utilizing the fact that the whole matrix is sorted. And if you know something about binary search, this should give off some alarm bells, the fact that it is sorted. Now, we're not going to be doing exactly binary search where we're going to cut it in half each time. However, it's going to be something very similar. So just to make sure we understand, basically, from the row, from left to right, it is sorted. So you see 4 is greater than 1, 7 is greater than 4 and 1, 11 is greater than 1, 4 and 7, and 15 is greater than 1, 4, 7, and 11. You can see that when we check each individual row, and then column-wise, from top to bottom, it's sorted from top being the least and the bottom being the greatest. So utilizing that fact, how can we search the target? And also here we are just outputting true or false whether the target exists or it does not. So in this example, we are asked to find a 5. We see it's right there, so we would return true. Here we're asked to return 20. If we look through it, we don't see it at all, so we can return false. Now, going through a brute force solution would literally be just linearly going through the whole matrix. So let's just code that out and see how it works. So we're going to go for int I is equal to 0, I is less than matrix dot length, I plus plus, for int j is equal to 0, j is less than matrix of 0 dot length, j plus plus, if matrix of I and j is equal to the target, then we can return true. Else, if we go through this whole for loop, we have to search the entire matrix with the outer for loop basically being the rows and the inner for loop being the individual columns. So if that's the case, then we can just return not -1 false. I'm just so used to like returning the indices, but yeah, we would return false. Let's see if it works. Yep, it does. So now let's run it. And we see that, it was successful. However, the runtime is pretty slow. It's 19 milliseconds, which is only faster than about 13%, or I guess roughly 14% of all the submissions. So we can do better than that. So what is the idea we are going to use? Well, basically, we're gonna search through this whole matrix by using the idea, by comparing, is this target, is whatever number we are currently hovering over or have selected, is it greater than or less than the target we are trying to find? If, for example, the target that the number we have selected is greater than the target, there's two ways we could go. We can subtract the columns, which will lower the numbers, since 26, 23, 21, 18, these are all less than the 30. Or we could go up a row, so going from 30 to 24 to 22 to 19 to 15. Likewise, if we were over here and we see that, okay, the target is greater than the number we have selected, there's two ways we can go. We can either go down, so we could go from 1 to 2, or we can go to the right, so all the way to 1 to 4. So we can search both of these. And the key comes when we realize that we can basically mix and match which one we choose. Of course, we can't start over here, since if we find that it is less than, if the target is less than whatever we are selecting, we are given two choices, either go up or to the left. And then same thing starting at this corner. Do we go to the right or do we go down? Choosing between these two corners, these two diagonals, the choices are clear cut. We just have one choice. If we start over here and we find that the target is less than whatever we have selected, we can just go up in rows. If it is greater, then if it is greater than that, then we can go to the right. if we start up here, if the target is greater, then we will go down a row, and if it is less, then we'll go to the left. So that's the general idea. So let's implement it. I will basically start from this corner, and the way we're going to search through it is that I'm going to use the same idea. If the target is less than what we currently have selected, then we'll go up a row, and then if it is greater, then we will go to the right. And we'll know we have searched through the whole thing. Not every element, but we know we can be confident if we don't find it. If number one, the row is at the very end, and also the column is at the very right, since that means we have basically checked through all our possibilities. So let's implement that. So I'm going to have an integer row, which is going to equal matrix dot length minus 1. So we're starting down here. And I'm going to have an integer column, which is going to equal 0. So it is starting, again, at the first, or the first element, or the 0th index. So for our loop, we're going to go until row is while it is greater than or equal to 0. So if it becomes less than 0, so if we went all the way up and then past it, and column is less than matrix dot length, or matrix of 0 dot length. So that basically means while the column is less than the length of the matrix in terms of the column wise. So if it is right here, that's fine. If we have to push it out, then that's not. If both of these conditions are false, then we know we are outside of the array and we didn't find a target. So let's do it. If matrix of row and column is equal to the target, then that's great. We can just return true because we found it. Else, if matrix of row and column is greater than the target, then if it is greater than the target, so we have a situation somewhere right here. So for example, if we were searching through this and we were at the 14 as an example, and we see that, okay, our target is 5 and we are at 14, we need to go up a row. So that's why we're going to do row minus minus. Else, the other case is like if we are over here at a 2. In this case, going up a row wouldn't mean anything, so we're going to increase our column. So column plus plus. And if we loop through this whole thing and we don't find it, then we know it doesn't exist, so we can return false. So let's see if it works. Okay, great. Now let's submit it. All right, great. So that was search in 2D matrix.